So this is a question from GATE 2023, and the question is, in the circuit shown below, the current I flowing through 200 ohm resistor is dash milliampere. So I need to find what is this current I. Okay, so the simple method is like we'll apply nodal analysis in the circuit. So I have one node here and the other node here. So let V1 be the voltage at this node and V2 be the voltage at this node. Okay, so here current I is equal to V2, which is the voltage across this resistor, by the resistance 200, right? So I need to find what is V2. So let us apply KCL at node 1. Okay, so at this node, if I apply KCL, so what is this current? So there is a current here. This current is V1 is a voltage across this path minus this 2 volt, that is a voltage across 2k, right? So V1 minus 2 by 2k, that is the current flowing through 2k, plus this current, that is voltage V1 by 2k, right? And plus this current is actually minus 1 milliampere, right? It's going to the node, so minus 1 milli. Okay, and here one path is there, that is like 1 milli, so 1 milliampere, plus there is a path like this. So this current is V1 minus V2 by 1k, that equal to 0, right? So I'll just club all the V1 terms. So V1 into, so I have 1 by 2k plus 1 by 2k plus 1 by 1k. Okay, so this minus 1 milli and 1 milli will be cancelled, right? So rest is V2, so minus V2 by 1k, and I have this 2 by 2k, so that I can take 2 RCS, so 2 by 2k. Okay, so V1 into, I can write as 1 plus this is 2 by 2k minus V2 by 1k equal to 2 by 2k. So I can cancel the entire 2k from LHS and RHS, and here it will be 4 V1 minus 2 V2 equal to 2, or if I cancel entire 2 here, it will be 2 V1 minus V2 equal to 1. So this is equation 1, right? Now let me apply KCL at node 2, right? So if I apply KCL here, so there should be a current flowing in this direction, which is equal to V2 minus V1 by 1k, plus there is a current, this one, right? So minus 1 milliampere, and there is a current like this, I current, right? So plus V2 by 200, that equal to 0. So I will bring 1 milli to RHS, okay, and let me club V1, so minus V1 by 1k, V2 terms is 1 by 1k plus 1 by 200, so minus 1 V1 by 1k plus V1 into, so I can write this as 1 plus 5 by 1k, right? So 5 into 200 is 1k, that equal to 1 milli. So I will bring 1k to RHS, so minus V1 plus this is V2. V2 into 6 equal to 1 milli into 1k, which is equal to 1. So minus V1 plus 6 V2 is equal to 1. So this is the next equation that I got from the node 2. What is the requirement? I need to find what is V2, right? So simple thing is like from this equation 1 and say this is equation 2, I will eliminate the value of V1, right? So what I will do, I will just multiply equation 2 with 2. Okay, so I will get minus 2V1 plus 12V2 is equal to 2. So this is equation 3. Okay, I will just add 1 and 3. So if I add this 1 and equation 3, the 2V1 plus minus 2V1 will be 0, right? Plus minus V2 plus 12V2, that will be equal to 11V2, that equal to 1 plus 2 will be equal to 3. So V2 will be equal to 3 by 11. Alright, the question is to find what is I. So what is I? I will be equal to V2 by 200, or this is equal to 3 by 11 by 200, right? Or 3 by 2200. So if I find this, the value will be equal to 0.00136. So the question is to find in milliampere. So this is equal to 1.36 milliampere. So answer is 1.36 milli. From GATE 2023, and the question is for the two-port network shown below, the Y parameters is given as matrix Y equal to 1 by 100, 2 minus 1 minus 1 4 by 3 Siemens. The value of the load impedance ZL in ohm for maximum power transfer will be. So the question is to find what should be the value of ZL such a way that maximum power will be transferred. So we know the ZL should be equal to the Thevenin equivalent resistance or impedance of the circuit, right? So so for this system or for this network, let this should be the voltage, input voltage V1 or the voltage at the port 1, and the current is I1, and at port 2 the voltage is V2 and this is the current I2. Okay, so this system I can write as the matrix I1 I2 equal to the given matrix Y, right? Y matrix, that is 2 by 100 minus 1 by 100 minus 1 by 100 and 4 by 300 into V1 V2, right? So if I expand, it will be I1 equal to 2 by 100 V1 minus 1 by 100 V2 and I2 equal to minus 1 by 100 V1 plus 4 by 300 V2, right? So since this Y12 and Y21 are equal, I can draw this network, two-port network, as like this, as a pi network. Okay, so where this is V1, this is V2, and I have current I1 and I have current I2 here. Okay, and this current will be equal to so if this is the resistance R1, say this is R2 and this is say R3, so this current will be equal to V1 by R1, and this current will be equal to so V1 minus V2 by R2, and this current will be equal to V2 by R3. Okay, so if I analyze this equation 1, okay, so I can have a term that is V1 minus V2 by R2 from this, right? So I can split this equation as V1 by 100 plus V1 minus V2 by 100, right, which is I1, right? I1 equal to V1 by 100 plus V1 minus V2 by 100, because this V1 plus V1 will be 2, right? 2 V1 by 100. So comparing this equation with the circuit, it's clear that, say this is the current, say IA flowing through R1, that is V1 by R1. So this is corresponding to this term, right? So IA, and say this current is IB, that is V1 minus V2 by R2. So that is this one, IB, right? So comparing these two, it's clear that R1 is equal to 100, right? This 100, and R2 is also equal to 100 from this equation. So I can split this as, say I2 equal to, I need V2 minus V1, so by 100. Okay, why I am taking like that? Because if I use the KCL here, the current I2 entering here will be split like this and like this. Okay, so this current is actually V2 by R3 and this current is actually V2 minus V1 by R2, right? So I need V2 minus V1 by R2, and if this R2 is already 100 from the previous relation, right? So it should be like V2 minus V1 by 100. So what will be the remaining term? So that will be plus 4 by 300 plus minus 1 by 100, so that both the relation is same, right? So V2 minus V1 by 100 plus by 300 plus minus 1 by 100. So I can multiply this term with 3 in numerator and 3 in denominator, so that denominator will be same, right? So 4 minus 3 is 1, so 1 by 300 V2, right? So again, if I compare here, I have R2 will be equal to 100 from this equation, right? And what will be the R3 here? R3 will be, I can compare with this, right? V2 by R3, that is V2 by 300 from this equation. So R3 is actually here 300. Okay, so if I draw it again, it will be like this. So 100, 100, 300. Okay, and I have V1 voltage here, I have V2 voltage here, I have current I1, I have current I2. Okay, so this is actually this network. Okay, apart from this, I have an input voltage 120 and 10 ohm connected in series, and I have a load ZL. So I can add that I have one 10 ohm resistor here. I have voltage source. So this voltage is 220 volt, and across this I have connected one load ZL. Okay, so I need to find what is the Thevenin resistance. So to find the Thevenin resistance, I need to remove all this source, voltage source. So I will short the source. So the equivalent circuit will be like this. So this is 10, this is 100, this is 100, and this is 300. Okay, and I need to find ZTH here. Okay, so if we see here, okay, this 10 ohm and 100 is in parallel. So if I take the equivalent resistance 10 parallel 100, this will be equal to 9.09, and this is connected in series with 100, right? So the net resistance, if I take the entire resistance like this will be equal to 100 plus 9.09, that is 109.09 ohm. Okay, so effectively this circuit will be like this now, right? 109.09, and I have some 300 ohm in parallel. So I need to find the equivalent. So equivalent ZTH will be equal to 300 into 1.09 by 300 plus 1.09, sorry, 109.09. So this is approximately equal to 79.9997, or it is equal to 80 ohm. Okay, approximately equal to 80 ohm. So this should be the resistance that should be connected for maximum power transfer. So the answer is 80 ohm. So this is a question from GATE 2023, and the question is, in the circuit shown below, the switch S was closed for a long time. If the switch is opened at t equal to 0, the maximum magnitude of voltage VR in volts is. So I need to find what is the maximum voltage VR when the switch is open. Okay, so first we will analyze what happens. The switch is closed for a long time. Okay, so when the switch is closed, okay, this is 1 ohm, this is 2 ohm VR, and I have an inductor here, right? So since the switch is closed for a long time and the voltage is a DC, the inductor will be short circuited, right? After a while, the inductor will act like a short. So what happens, whatever the current flowing like this, it will flow through the inductor and will come back to the source itself. So what is this current I? Okay, since this is short, what is the effective resistance here now? 1 ohm, right? It is like 1 ohm kept in series to the 2 volt voltage source, right? So the current I now is, I will be equal to 2 by 1 or 2 ampere. Okay, now what happens when it is switch is open circuit, so or switch is kept open? Okay, so this is the voltage source. Okay, so what happens when suddenly, so there is one inductor here, so when suddenly the switch is open, so what happens, the current is actually ceasing here, right? This current will be 0 ampere because it is open, but still the inductor will try to flow that current through this path. So I can draw this like this. There is a current source like this. Okay, it will try to flow this current in the same direction as this direction. And what is this current? 2 ampere, and slowly it will cease down. Okay, so what happens to this current? This current will flow like this, and will it go like this? This will be 0, right? Instead it will go like this. This will be 2 ampere. Okay, so we have the VR like this. So what is VR actually? VR is actually 2 into 2 ampere initially, and it will cease down. It will go to 0. Okay, so VR is minus of this. So mode VR will be equal to 2 into 2 ampere, that is 4, right? 4 volt. So answer is maximum voltage will be 4 when switch is open. So this is a question from GATE 2023, and the question is, the switch S1 was closed and S2 was open for a long time. At t equal to 0, the switch S1 is opened and S2 is closed simultaneously. The value of IC 0 plus in ampere is. So when S1 is opened and S2 is closed, what will be the current IC initially from the capacitor? That's what the question. Okay, so first we will draw when before the state of this network when t is less than 0, right? That is when S1 is closed and S2 is open. Okay, so if I draw that, Okay, so this is what happened. So when S1 is closed for a long time and S2 is open for a long time, what happens? What happens to this capacitor? It will be like an open, right? It will be like an open circuit because it's a DC current. Okay, while there will be a voltage drop across this capacitor, or the capacitor will be charged in such a way that it will be having a voltage. I will call it as VC. Okay, and since the current is DC, what happens to this inductor? It will be like a short. Okay, so effectively I can draw this as two resistance kept in parallel. This is 100 and this is 25 ohm. Okay, so we'll see what is the current through the inductor, that is IL. That is the current through this 100 ohm. Okay, so what is IL? IL is equal to here the current is 1 ampere, right? So 1 ampere into the opposite resistance 25 by 100 plus 25. That is 1 into 25 by 125. So it is like 0.2 ampere. That is a current in IL. Okay. Similarly, what is the voltage VC? VC will be the voltage across this node, right? So that is like, since the current is 1 ampere that is flowing here, what is the voltage across this equivalent resistance? So equivalent is like 100 ohm parallel to 25. So VC is equal to 1 ampere into the equivalent resistance, that is 100 into 25 by 100 plus 25. So it is 100 into 25 by 125, so 5 times, so it is equal to 20 volt. So when switch S1 is closed for a long time and S2 is open, the voltage across the capacitor built will be equal to 20 volt and the current flowing through inductor will be 0.2 ampere, right? So I can draw the circuit. Okay, so we'll draw the circuit for t equal to 0 or greater than 0. Okay, so that is now when switch S1 is open. Okay, so when S1 is open, I have this capacitor, and that capacitor, I'll say this is the ideal capacitor, 0.01 farad, and there will be a voltage source, right, which is of 20 volt. So instead of drawing this capacitor, I will draw a voltage source kept like this, 20 volt. Okay, and this is the current IC 0 plus, and there is one resistor like this, and here also resistor. So here the switch is closed, right? S2 is closed, and here I have the inductor. So instead of inductor, I will draw a current source, because the current won't change abruptly or instantaneously and across the inductor, right, through the inductor. So the inductor will try to flow the same current which was there at t less than 0. So I can draw it as a current source with 0.2 ampere like this. Okay, so this will be the equivalent when at the instant when t is equal to 0. Okay, so since this is short circuited, I can draw this. Instead of this, I can remove this 100 ohm, right, because this is short circuited. So I can draw like this because S2 is shorted. Okay, now we'll see what is the current IC0. Okay, so from here, since there is a voltage drop of 20 volt across this node, right, there will be a current flow like this. So what is this current? This current will be equal to the voltage across 25, that is 20 by resistance 25. So there is a current flow like this, and also there is a current flow like this, that is equal to 0.2 ampere. Okay, so applying KCL here at node 1. Okay, so IC0 is the current this plus 0.2 ampere plus 20 by 5 is will be equal to 0. So 20 by 25 will be equal to 0. So what is IC0 plus? This will be equal to 0.2 minus of 0.2 plus 20 by 25, right? So minus of 25 into 0.2 is 5 plus 20 by 25. So it is equal to minus 25 by 25 or equal to minus 1 ampere. So IC0 plus is minus 1 ampere. So answer is B.